This is a Bond's curve. It gives you the distribution. If you take any element or any gas for that matter, anything, this gives you the distribution of energy of the particles. And on this x-axis the energy, and in this the proportion or the fraction or the number, whatever you can think of. So what is and the fraction actually, and this is this area is the number. This area, number of particles. So have like if this is the energy, these particles have energy greater than this energy, and these particles have energy less than this energy. So this is like normal distribution in maths probability curve. So it's like very like the normal. So what happens is if you increase the temperature, the curve shifts. So what does it mean in that the curve shifts? It means that if you got if this is the curve, this is the distribution of energy at 25-degree, this curve, then this curve is 100-degree and this curve is 106. So as you are raising the temperature, the curve kind of flattens and shifts to the right. It flattens and shifts to the right. This is if you increase the temperature. Acha, how does that affect? You see, if you got something with this activation energy, if you increase the temperature, the curve is flattened. So initially only these particles had energy more than this is the activation energy. Now these many particles have energy more than the activation. So now they are, so what will you say? You will keep this in mind and you will say if you increase the temperature, the number of particles having more energy, number of particles having a, a you say the energy of the particles will increase. First thing is obviously you will say the energy of the kinetic energy or the energy of the particles of all the particles increases. That's why it kind of flattens. It goes towards the right because now more are having greater energies. That's why it flattens and goes towards the right. But you don't have to say that. You say if you increase temperature, the energy of all the particles increases. Then the most important line, the number of particles having having energy more than the activation energy, that increases. Having energy more than activation energy, because this area has increased, because the curve is shifted, flattened. This, and that is why then you say so more particles will have successful collisions. Acha, the energy of all the particle increases and the collisions will increase. You say collision frequency will increase. But now you say because the number of energy more than the activation, these are the important particles. More particles will have successful collisions, or which will result in a product formation. And that's why the rate of reaction increases. So let me see what they have written. Let me see what